Welcome to another video from Your IT Explained. In this video we're going to cover troubleshooting of manual and auto summarization with any routing protocol as a theory lesson. So this topic comes directly from the Cisco CCNP ENARSI exam blueprint 1.5. So to begin with, let's just cover off on what route summarization is. So it's simply just combining multiple routes into a single, less specific route. You can consider it basically the opposite of subnetting in that sense. So you'll have multiple different routes, you summarize them into one route with a less specific subnet, basically. So let's look at how we can do this practically. So we've got these three networks, 10.0.0.0, 10.0.1.0, and 10.0.2.0. We want to find a summary address that will capture all of those addresses in one. So what we first do is we can write these out in binary. This is how we can determine what the best summary address is. And then once we've done that, similar to what you do with subnetting, is we look through the binary until we find the first bit that is different across all addresses. So all of the bits are the same until the third octet and 7 bits in. Because we see on 10.0.2.0 it's a 1 versus the other two networks, they're zeros. And so what we do is then in binary we'll then change all of the bits that match to ones, and then from the first bit that is different onwards we change that to a 0, and then if we look at the end result, it's this subnet down here, so 255.255.252.0, which is a /22. So if we apply that to the original lowest network, which would be 10.0.0.0, we give it a /22. That will capture all of these addresses in one summary address. But as I've put down here, we could also just do a /8. We could do 10.0.0.0 with a 255.0.0.0 subnet mask, which is /8, and that still works, right? That's still a summary address that covers all three of those addresses. But that is not it's not specific enough because that's going to capture way too many networks. So yeah, we could just do the first octet as ones and then the rest zeros. But the idea of when you're using a summary address is that you're being as specific as possible while capturing all of your necessary addresses. So this is, I guess, kind of important to note that sometimes you might hear this being referred to as supernetting versus subnetting. So route summarization is sometimes just called supernetting. Alright, so let's have a look at this example configuration where we've got three routers. The blue IP addresses are just these example networks that are hanging off of router 3 and router 4. And then if you're not using any route summarization, what would happen is that router 3, for example, would advertise both of those two networks across to router 2. Router 4 would do the same thing. It would advertise both of those two networks to router 2. And then router 2 would advertise all 4 of those networks up to router 1. But if we use route summarization, it can look more like this, where router 3 summarizes both of those addresses into a /23, and router 4 does the same thing, a /23, but starting at 10.0.2.0 to capture its two networks that it's advertising. And then router 2, it can then summarize those two summary addresses as well. So we can break them down into a /22. So 10.0.0.0/22 captures all 4 of those blue networks. And so this is quite handy because it reduces the amount of traffic back and forth between devices when you no longer have to advertise 4 networks or 400 networks. If you can capture that all in one route advertisement, then there's a hell of a lot less traffic going all around the network with, if you're using like a link state routing protocol, keeping all the links together, or whatever you may be using. If it's configured correctly, it can drastically improve the performance of the network. And so this is quite important when you consider the way that the internet works. At a bigger picture, route summarization is essential. If you try to get every network advertised specifically, it'd just be intense for all of the equipment that's got to try and maintain all those addresses. Alright, so now we can start. Now that we know what route summarization is, we can start to consider the difference between manual and automatic route summarization. So some routing protocols, they do support auto-summarization, so RIP version 2, EIGRP, and actually BGP. Otherwise, we specify the summarization manually. Now, the thing to consider with auto-summarization is that means it's going to revert to classful addressing. Specifically, like we consider what we saw in a previous lab when we were redistributing BGP into RIP. RIP automatically, by default behavior, summarizes addresses in a classful manner. So we saw that it was summarizing addresses, like I think it was a /8 that it summarized when we were actually using a /24, just because the first octet was indicative of a class A address range. So yeah, there's these two options where you can manually specify or automatically specify, but you need to be careful and make sure that you are using the right type of summarization for you. Now, if we consider OSPF's options when it comes to summarization, it's used on the ASBR, so something that's connecting OSPF to some other routing process rather than an ABR. So we use that like if it's redistributing some other routing protocol into OSPF, it's at that point where we'll configure or can configure the route summarization. Now the second point that's important to note is that you cannot summarize an address or any addresses which have 0 subordinate routes in the routing table. So what that means is you need to have a way to reach at least one of the addresses in that summary address you're trying to push through. Otherwise, it just won't be populated into the routing table. So the example here is if you run show IP route and you've got no 10 dot whatever routes, using any summary address that starts with 10 dot whatever, it won't be added to the routing table. You have to already have some route to a network within that summary range in order to use that summary address range, which makes sense. Why would you be advertising a summary address range for networks that you have no reachability for whatsoever? It doesn't make sense. Alright, so this is just an example. This is all like hypothetically in some OSPF area 0 network. Those 10, the addresses that are red are the example summary addresses that we saw before. Now you wouldn't be able to use those within an OSPF single area because we configured the route summarization on the ASBR. So if router 1 was connecting off to EIGRP or BGP or something else, then we could summarize on router 1. But typically, this is not how we would. This is not how you can use the route summarization in OSPF. Now, if we consider BGP instead, BGP we can manually specify or choose to put in the route summarization. But there is also an additional word that we want to add in if we are going to just advertise the summary route. So we use the aggregate address command to advertise an aggregate address or a summary address. But the default behavior when you do that is it's going to advertise the summary address and all of the other addresses together. So let's have a look at what this looks like. So on the left, top left, we have a image from the running config on router 1, and we've just put in to the router BGP 100 the aggregate address command to advertise a summary address into BGP. And so this is coming from the known OSPF routes. But what we see on the next device, so this is, I think, router 9, which is also running BGP. It receives the aggregate address that we put through. We can see it on the first line in the routing table. It's got the 10.0.0.0/22, so it's receiving that aggregate address, that summary address, from its BGP peer, but it's also receiving all of the individual addresses down below. So we can see these addresses from 10.00 to 10.03. They're all within that summary address. So we're kind of doubling up here. Now if you want to fix that, it's a quite simple fix. All we do is we add summary only onto the end of that command. So you're only advertising that summary address. And then what we see on the BGP neighbor is that summary address is still there, but we no longer have all of those other additional ones. So I go back, we no longer have the 0, 1, 2 or 3. They're all gone because they are within the summary address range. We still have 4, 5, and 6 though, because those network ranges do not reside within this summary address. If we wanted to include those as well, we would then have to drop this to a /21, for example. Now then, instead of manually specifying, we could instead just do auto summary. So if you do auto summary in BGP, it will automatically summarize for you without you specifying anything. And then we see on the next device, this is the result. It's summarizing a /8 address range automatically. So this is one of the trade-offs of using automatic summary, is that it will use the class full address advertisement based on the address ranges that you're using. And so this, although it does indeed capture, if we go back, all of these addresses that we want to advertise, it's also including a ton more of addresses that we don't want to include. Well, maybe you do. Maybe you do want to include them for expansion or for whatever reason, but you just need to be aware that this is how it operates, this is how it works. So you've got to weigh up whether you want to just use auto summary or if you want to manually specify it like we did here with the aggregate address command. Okay, so now, another little issue with the route summary is that if you are using route summarization and one of the networks that is inside of that summarization range is dropped, lost, or removed, then it's not necessarily going to be removed from the routing table because it's all within that summary address. And so devices are still going to continue to send traffic destined for that network even though it's no longer available. So it could result in some extra traffic going around your network even though you know that that network no longer exists. So this is another one of those little trade-off things that you need to consider whether you want to implement that or not. Alright, and then just to finish off, here's just a list of some commands that are relevant for route summarization. So we've gone through these first two in BGP, the aggregate address command with summary only on the end, if you want to only include the summary, or we can use auto summary. And then with OSPF, it's simply in the OSPF process saying summary address and then specifying what you want to summarize. In EIGRP, in the EIGRP process, you can specify auto summary. So you can use this within the EIGRP routing domain. So you might have EIGRP neighbors all connected together. You can use it within the EIGRP environment, And then the last command here, IP summary address EIGRP autonomous system 100, and then the actual summary address that you're advertising. This is specified on an interface. So this is an interface command. So you might go into your specific interface and then advertise a summary address outbound on that interface by using this command. Okay, so that's basically it for the theory. To solidify the understanding, as usual, we'll go through a lab video where we test out a few different things with summarisation, and hopefully answer any lingering questions or uncertainties that you might have. Aside from that, thanks for watching. Feel free to put any comments down, support the video as you see fit, and I'll hopefully see you in the next one.